Hi, ladies and gentlemen. Let me wholeheartedly welcome you to the fifth session on ECT 204 Signals and Systems. In this video, we understand the meaning of the frequency of discrete signals. Now, the contents of today's presentation are your learning outcomes, then the frequency of discrete signals, and then we understand that the the frequency of discrete signals is not unique, then the summary of understanding. So what you will learn to define the frequency of discrete time signal and learn its range. Then you will understand that the digital frequency is not unique. I mean, the frequency of discrete time signal or digital signal is not unique. In the last presentation, you understood that an analog signal or a continuous time signal can be faithfully represented by its samples. And by sampling theorem, you understood that a signal can be a real signal or a continuous time signal can be faithfully reconstructed if two or more samples are taken from a period. So the concept of the frequency of such a discrete signal is different from the frequency of a continuous time signal. For a continuous time signal, the frequency is the number of zero crossings in a second. That is, you observe the signal for a second, and if you see, say, 500 zero crossings, it has a frequency of 500 hertz. If you see 1000 zero crossing, then it has 1000 hertz. That is not the concept of frequency for a discrete time signal. Here the frequency is defined as the number of cycles per sample, or it is actually the inverse of the number of samples taken out of a cycle. Okay. It is the number of cycles per samples. Frequency small f. Throughout the lecture series, I will represent the frequency of a discrete signal with small f and its angular frequencies by small omega. The frequency of the discrete signal f is defined as the number of cycles per sample, or it is inverse of the number of samples per cycle. That is, if I take 4 samples out of a period, then the frequency will be 1/4 cycles per sample. Okay. If I take 8 samples out of a period by sampling, if I take 8 samples out of a period, then the frequency of the resulting discrete signal is 1/8 cycles per sample. And what is the maximum frequency? What is the minimum number of samples needed by sampling theorem? It is 2 samples. You need to take at least 2 samples out of a period. So that is the minimum number of samples. So the maximum frequency should be 1/2. So the frequency of the discrete signal that spans in the range minus half to half, or the angular frequency omega ranges from minus pi to pi. Now this is something very bizarre, because all continuous frequencies from minus infinity to plus infinity are mapped onto the small interval minus half to half upon sampling. Now look at this signal. This is my continuous time signal. This is sampled by this impulse train. Now there are 8 impulses in a period. So that means 8 samples are taken out of a period. So the frequency of the signal is 1/8 cycles per sample. I have taken 8 samples out of a cycle. So the frequency is inverse of that. That is 1/8 cycles per sample. Here it is sampled at a lower frequency. So you can see that the sampling rate is less. I have taken only 6 samples out of a period, so the frequency of the resulting discrete signal, that is the frequency of this signal, the sampled signal, is 1/6 cycles per sample. Now observe that the total analog frequency, or the continuous frequency range from minus infinity to plus infinity, they are mapped on to the discrete frequency range minus half to half upon sampling. And observe also that the small f is a continuous variable ranging from minus half to half. That is, small f is continuous from minus half to half. This means that though the signal xnts, or the sampled signal, is discrete time, it is not discrete in frequency, because the frequency small f is a continuous variable from minus half to half. Now another point of importance is that small f, or the frequency of a discrete time signal, is not unique. That is, if I sample a 200 hertz signal by a 1000 hertz signal, the resultant discrete signal has a frequency of 200/1000, that is a 0.2 cycles per sample. Likewise, if a 400 hertz signal is sampled by a 2000 hertz signal, then also the resulting discrete frequency will be 0.2 cycles per sample. So whenever you mention the discrete frequency, you have to be sure about what is that sampling frequency. Only when you sample the when you mention the sampling frequency, you can make sense out of that. So this means that the discrete frequency is not unique unlike analog frequency. Analog frequency or the continuous time frequencies are unique. Like 400 hertz is different from 200 hertz, that is different from 1200 hertz. They were all unique. But the discrete frequencies are not unique. So you have to specify your sampling frequency also to make sense. So again, any frequency outside the range minus half to half is identical to a frequency inside this range. For example, if someone says there's a frequency of 9 by 8, that is equivalent to 1 plus 1 by 8, that is 1 by 8 cycles per sample. So any frequency outside the interval minus half to half is a frequency inside that range. Now coming to the end, you defined the frequency of a discrete time signal and learned its range. You understood that the frequency of a discrete time signal is defined as the number of cycles per sample, or it is the inverse of the number of samples taken out of a cycle. That is, if you take 8 samples out of a period, the frequency of the resulting discrete signal is 1 by 8. If you take 4 samples out of a period, the frequency of the resultant discrete signal is 1 by 4 cycles per sample. And the maximum frequency is half, because by sampling theorem you have to take at least 2 samples out of a period. So the maximum frequency is a half. So the range of frequency is from minus half to half. You have to see that this frequency range is continuous. So even though the signal is discrete in time, it is not discrete in frequency, because frequency is small f is a continuous variable from minus half to half. And you understood that the digital frequency is not unique. So because all continuous frequencies from minus infinity to plus infinity are mapped down to the small interval, interval of discrete frequencies from minus half to half upon sampling. So only if you specify the sampling frequency also, it makes sense. And that is the end of this presentation. I thank you all.